Hello friends, today I am now going to discuss complex function or complex number in very detail. In this series, we will discuss complex number and from basics to advanced level. So stay connected with our YouTube channel from very beginning to and from very last of the lecture series of this complex number series. So let's start this complex number series. So actually, what is a complex number actually? Firstly, we have to know real numbers. Real numbers means what? Real numbers means suppose 1, 2, 3, 4, dot, 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 etc. Okay, there are some numbers. There are some numbers which are not real. Not real means what? Firstly, not real means what? Not real means that has no existence in real world. That means that is imaginary. Okay, that is imaginary number. So what is actually imaginary number? Imaginary number means actually we can write for real number we can write suppose -1, -2, -3. We can write this. We can write this thing. But when we do the square root of this negative real number, when we do the square root of this negative real number, then that would be turned into imaginary or imaginary number or not real number. Imaginary number means suppose I am writing -1. So this is imaginary number and this can be written as root over iota square and that is actually iota. Yes, this is actually imaginary number and iota, it is defined as iota. Iota. Yeah. So let's represent the Cartesian form of complex number. So firstly, then it is 1, 2, 3, -1, -2, -3, etc. These are real numbers. These are real numbers. And imaginary numbers, first not complex. And imaginary number is what? Imaginary number, suppose I plus minus I plus minus 2 iota plus minus 3 iota, etc. These are imaginary number. But now what is complex number? Suppose you write something, some number such as 1 plus 2i. In this part, this is real number. And here with iota, this term, this is imaginary. So when we write a number with mixed state of real plus imaginary, that is known as complex function. Don't mix complex function with imaginary function. Actually, complex function is what? Complex function is mixed with real and imaginary both. Imaginary is on purely imaginary means purely imaginary. That doesn't contain real number. Here, no real number. Similarly, in real number, it doesn't belongs. It has no content of imaginary number. It is only real number. But complex, in case of complex numbers, for complex number, it consists of real plus imaginary. Real plus imaginary means suppose you have a real number x and another imaginary number y. So you can write that complex number form as x plus iota y. So let's represent the Cartesian representation of complex number. For for real number in Cartesian coordinate, what we can do that for Cartesian coordinate we can write two axes. One is x, that is horizontal axis. One is x and vertical axis y. But when we will write the Cartesian form of the complex number, we have to write x and iota y. Here it is real axis. Here it is imaginary axis. Here it is real axis, here it is imaginary axis. Suppose there is a point. Suppose name that point as A. Suppose there is a point A in this coordinate form, in the Cartesian form of complex. So you can write this point, suppose 2 and it is 3. So this is a coordinate of this point. So how can we represent in terms of Cartesian form of complex number? You can write it as, here it is x, here it is y, 2 plus 3i. So this is a Cartesian form of complex number in the complex Argand plane. Yeah, actually this is xy, not real plane. This is complex Argand plane. Yeah, this is complex Argand plane. And how to let us show you some important things of this complex Argand plane. We know that first write the coordinate. Here x, here it is iota y. Okay, here x and here it is iota y. Now here draw a line r that is making an angle theta with respect to horizontal. Now this is a line, this is a line. Suppose this point is P and here it is x comma y, here it is x. X equals here x equals r cos theta, and this is y. Y equals r sin theta. How you can you must know this. How I can write this? Actually, cos theta means what? Cos theta means bhumi by otibhuj. That means base by hypotenuse. Base is what? Base is here x, and hypotenuse is here r. So we can write it as x by r equals cos theta. So this component as x equals r cos theta, and this as y equals r sin theta. Sin theta equals what? Sin theta equals actually perpendicular by hypotenuse. So y by r equals sin theta. So y equals r sin theta. So this is a complex in the complex plane. This is a representation. Now actually, what's my purpose? To show you that whenever we'll write this complex number in terms of theta, suppose z equals x plus iota y. Now x equals r cos theta. Let me write. Suppose x equals r cos theta and y equals r sin theta. R cos theta plus iota r sin theta. Now take common of r. R equals cos theta plus iota. Let me write. Plus iota sin theta. So we can write it as r e to the power iota theta, where e to the power iota theta equals cos theta plus iota sin theta. This is actually what? This is actually Euler's theorem. E to the power iota theta equals cos theta plus I sin theta. Now an important thing you have to know here, what is theta here? I have drawn that theta actually whenever I am drawing x and here it is iy. Okay. Now this r is making an angle theta with respect to what? With respect to here horizontal. Theta is actually argument of z. Argument of z. Arc z. Theta is actually arc z. Arc z is actually what? Arc z is, it is the angle made by the complex number. Here actually it is what? It is the complex number, position coordinate of complex number. Argument is the angle made by the complex number with real axis. Here it is real axis, and complex number is making an angle theta with respect to what? Complex number is making an angle theta with respect to real axis. That is known as arc z, argument of z. Now if theta is anticlockwise, theta is measured anticlockwise means what? Here it is anticlockwise direction. Let me show you by changing plane color. Suppose theta is in this side, anticlockwise, then it will be positive. But if theta is clockwise, then it will be negative. Here it is positive theta, here it is negative theta. So this is a complex number, actually introduction of complex number. Now complex conjugate, you have to know that this is a complex number in the Cartesian plane, and complex number, so what we know here, we have come to know here that z equals z equals x plus iota y. So z, it can be written as also r e to the power iota theta. This is the representation of the complex number. So here it is the in the polar form of polar form in the complex number. Here it is the Cartesian form. And here what is theta? Theta is actually argument of z. Argument of z means what? Small argument of z is actually the angle made by the complex number with what? With real axis. Always remember this. And theta if anti-clockwise, then it will be positive, and theta if clockwise, then it will be negative. Now we have to know that what is a complex conjugate of a complex number. Whenever we are writing z equals x plus iota y, and if we are taking the complex conjugate, that means complex conjugate of x plus iota y. Always remember, complex conjugate means here z star complex conjugate means z star is the image of j with respect to x axis. Let me here it will be actually what? Here it will be actually x minus iota y. Always remember this iota, this sign of iota will be changed. When we are taking the complex conjugate of any complex number, then the real term will not be changed. Real term will not be changed. It will remain invariant. It will remain unchanged. But the iota means it is deleted. This iota term will be changed. If iota is plus iota, then if you take complex conjugate, then it will be minus iota. This iota term will be changed. Let me show you by graphical representation. Actually, graphical representation means whenever you are drawing a complex number. Here you are drawing a complex number. Let me change the pen color. Sorry. Here it is x, real axis. Here it is iota y, this imaginary axis. Here you are drawing a complex number r, here p at x comma y, and here it is the argand plane, arc z theta, and it is taken as anti-clockwise positive. So anti-clockwise means theta has been taken positive. Now if you take the mirror image of this means with respect to this plane, with respect to real axis. With respect to real axis, if you draw a mirror image of this, you will get here also a complex number, but now theta is on which side? Theta will be negative, because why theta negative? Here it is clockwise direction. Theta is measured as clockwise direction. Theta is negative. So you can see that here the point will be what? X comma minus y. Here the coordinate will be x comma minus y. So it is the complex. Here it is, if it is a complex number z, here it will be a complex number z star. Coefficient of iota is what? Coefficient of iota is y. The sign of y has been changed. That means if we take complex conjugate of any complex number, then only the coefficient of imaginary part will be changed, and z star is the image of z. Z star means complex conjugate of any complex number is the image of z with respect to what? With respect to mirror is what? With respect to real axis, with respect to x axis. Always remember, complex conjugate is the mirror image of complex number. Let me write that. Complex conjugate is the mirror image of complex number with respect to real axis. It's very important thing. That you should know. Some important properties that I am now discussing here with you. That properties of complex number. Properties of complex number means what? Suppose you have a complex number z1 and another complex number z2. Now if you are doing plus addition, and if you are doing bar means complex conjugate. Properties of complex conjugate. So it can be written as z1 bar plus z2 bar. Similarly, if you do z1 minus z2 bar, it will be remaining as z1 bar minus z2 bar. multiplication of complex conjugate will be z1 bar, z2 bar. Okay. If you do division of the complex conjugate, it will give you z1 by z2, that bar, it will give you as z1 bar divided by z2 bar. Yeah. Similarly, another important formula that you should know, another important formula is x plus iota y equals z. Z star equals x minus iota y. So if you write the real part of z, that means x, it can be written as half into z plus z star. It's very important formula. Write it clearly. Half into real part of complex number equals half into complex number plus complex conjugate number. Half into z plus z star. Similarly, imaginary part of complex number, it can be written as y equals 1 by 2i z minus z star. Yeah. Where r is what? Now, one important thing I have forgot to tell you. Oh, sorry. What is r? That we were drawing this complex Argand plane, and here we are taking r. R is actually modulus of the complex number. Modulus. Modulus of the complex number means what? Suppose you are writing z equals x plus iota y. Here you are drawing that complex plane. Here it is r. Here it is x. Here it is y. So r can be written as modulus of this complex number. R equals mod z can be written as root over x square plus y square. It is very, very important. Real part square plus imaginary part square. So that is a modulus of the complex number. So let me continue that properties. Another important properties of the complex number will be z1 into z2 mod equals z1 mod modulus of z1 into z2 mod. Similarly, another important property is z1 by z2 mod. It will be same as z1 mod by z2 mod. Now, the one of the most important property, z1 plus z2 mod less than equals, not equality sign, mod z1 plus mod z2. Another important property, z1 minus z2 mod greater than equals z1 difference. This is not minus sign, this is positive difference. Let me clear you this property. Actually, when you are writing z1 minus z2 mod, these will be greater than equals mod z1 difference mod z2 difference. It is positive difference, not minus, not negative or not minus. Another important thing, I'm proving you that that important property, that how will you write z1 plus z2 mod less than equals z1 mod plus z2 mod. Yeah, z1 plus z2 mod less than equals z1 mod plus z2 mod. So if you write z1 equals what? Z1 equals r1 e to the power iota theta 1. You have recently come to know about this format. And z2 equals what? Z2 equals r2 e to the power iota theta 2. So how can we write z1 plus z2? We can write z1 plus z2 as z1 plus z2 mod equals r1 e to the power iota theta 1 plus r2, let me write r2 e to the power iota theta 2. So after doing the all calculation, breaking that e to the power iota theta 1 plus e to the power iota theta 2, you will get here equals r1 cos theta 1 plus r2 cos theta 2, this is real part, plus iota r1 sin theta 1 plus r2 sin theta 2. Let me write clearly, otherwise you can't understand. Whenever we are writing z1 plus z2 mod, and after putting z1 equals r1 e to the power iota theta 1 and z2 equals r2 e to the power iota theta 2. Now if you break r1 equals e to the power iota theta 1 equals cos theta plus iota sin theta, After doing that calculation, the part that will be remaining, that is r1 cos theta 1 plus r2 cos theta 2 plus iota into r1 sin theta 1 plus r2 sin theta 2. Yeah, here it is the real part and here it is the imaginary part. So now if you take the modulus of this z1 plus z2, so modulus means what? Modulus means, you have recently come to know about that. Sorry, here it will be z1 plus z2 will only. z1 plus z2 mod will be root over that real part square, r1 cos theta 1 plus r2 cos theta 2 mod square plus r1 sin theta 1 plus r2 sin theta 2 mod square whole square. Sorry, r1 sin theta 1 plus r1 cos theta 1 plus r2 cos theta 2 mod square whole square plus r1 sin theta 1 plus r2 sin theta 2 whole square. Now if you break this, after breaking this whole square term, at last you will get root over r1 square plus r2 square plus 2 r1 r2 cos of theta 1 minus theta 2. You will get at last this. Now cos has limitation of value. Cos theta 1 minus theta 2 has limitation, that is it is less than equals 1. Theta 1 minus theta 2 is the phase difference. So from here we can say z1, let me write clearly, z1 plus z2 mod, it will be less than equals r1 square plus r2 square plus 2 r1 r2, because cos theta has value less, cos theta 1 minus theta 2 has value less than equals 1. So r1 square plus r2 square plus 2 r1 r2, so less than equals r1 plus r2 mod square. So z1 plus z2 mod equals z1 plus z2 mod less than equals r1 plus r2. Okay, so r1 equals what? R1 equals mod z1. R2 equals what? R2 equals mod z2. So z1 plus z2 mod less than equals mod z1 plus mod z2. Yeah, so this is an important property that we have recently come to know. So that is it for today. It is introduction part. I will try to discuss in detail in this complex series, and I will make a detailed series on this complex part. Today is now only introduction part, introduction of complex number. I will make a detailed series on this complex number so that you'll get some little bit help. So that is it for today. Thank you all for patiently watching my video and keep supporting. Thanks for today. Bye.